Here. All right. What sensor measures the load on the engine? According to your, did you look that up? What
The
sensor?
map sensor.
I mean, how does it do that? I mean, how does it know from looking at the map sensor what the engine load is?
That's where I got it from.
Let me see if I can zoom out on that a little bit. I think I zoomed in too far. Just tell me what you think. What is MAP actually measuring? Got any idea? See, I mean, if you just answered the question right and you couldn't explain it beyond that, you really didn't learn anything, did you? Okay, so what does the letters MAP stand for?
Manifold absolute pressure.
Manifold absolute pressure. Now, how does that tell, once again, how does that tell the PCM what the engine load is?
But however much pressure the manifold has.
Well, you're using the words. Very nice. Okay, you know that when your throttle plate is closed and the engine and the pistons are doing their thing, they're basically going to be pulling against the throttle plate. It's vacuum, right? And so a healthy engine is going to have, if it's just idling and it's not under load, is going to have 18 to 22 inches of vacuum. That's why your vacuum gauges you buy and you plug them in are going to be floating in that green range of 18 to 22. If the vacuum's low, or if it's bouncing or something like that, you can basically, it's an indication of how well the engine's breathing. If you go into your throttle pretty deep, then you're basically going to see your vacuum drop. If your vacuum drops, what happens is the PCM is going to add fuel because it's going to see the thing is being under load. Okay. And so basically the sensor that measures load on the engine is manifold absolute. So low vacuum means high load. All right. Now also, incidentally, Taylor, the Ranger is a no start, by the way, so you need to dig into that with your scan tool and whatever and see what you can come up with it. But if you have a situation where you've put a cam in there, let's say you've cammed up an engine, you know where you cam it up and it gives it more. What does it mean when you put a cam in there? Anybody know? When you cam it up, how does it change the way it runs?
You use your exhaust valve and intake valve and more generation.
Yeah, basically lift and duration. Of course, you can give just one if you want to, but lift and duration would be the things that you're going to change. Okay, that changes engine vacuum. If you change engine vacuum, if I've seen this one guy rebuilt this Bronco, an old Bronco, 73 Bronco, and he put a Mustang engine in it, and he had cammed it up, and it had a map sensor that was supposed to tell it about engine load. Well, when it was idling, it had low engine vacuum, and the low engine vacuum caused it to run really, really rich at idle. Got me? And so how do you fix that? You don't want it running rich at idle. It ran just fine driving down the road because it had higher vacuum. So what would you do to take care of that? We got a mass airflow kit, which came with an engine controller, some harness, and a mass airflow sensor. It was actually adjustable. That took care of the problem. Okay, a TP sensor is what type of sensor? It is voltage generating, potentiometer, piezoelectric, or a rheostat.
Potentiometer.
It's a potentiometer, and the way that works is basically got a little piece of resistive paint in it. Got 3 wires going to it. It's got reference voltage, it's got signal return, which is a ground, and one of them, the one in the middle, varies, the voltage varies from about a half a volt to about 4.6 as you go up and down your throttle. Now if you operate that throttle really slowly and you're watching it on a voltmeter or a scope and you see it drop out, if it drops out on the scope, it causes her to drop out, okay? If you hold the throttle all the way to the floor on a lot of these cars, I've showed you guys some of that kind of stuff on most cars that have clear flood mode. If you hold it all the way to the floor, you're wanting to go through there without, a bunch of air to get pumped through there without squirting gas in there so it'll dry off the spark plug, right? That's clear flood, because it's when it flooded, the spark plugs get wet, the spark runs on the wet and doesn't jump across the gap, it won't start. When you hold your gas pedal down, it starts drying all of that off of there because you're not squirting gas in there and all that. That's why I tell you, if you wanted to impress your girlfriend at the burger barn over there, if you mash your gas pedal all the way to the floor and you spin it over and it doesn't start, and you just say, stay in the car, I'll fix this, and you go out here and pretend to do something, you come back and start, she thinks you know how to fix something, see? Anyway, that works. That appeal to you there? You can do that too. Except Taylor would know what you were up to, right? Okay. What sensor measures the temperature of the engine coolant?
ECT sensor.
What? ETC? Or what do you say?
ECT.
ETC?
ECT.
ECT sensor, engine coolant temperature sensor. All right, now how does that work? How am I gonna look at a sensor and tell what my coolant temperature is? You remember the signal return I was talking about going to the throttle position sensor? That's a ground going to the computer. All right, through a little current limiting resistor, or I'm gonna actually run a line out to that sensor and it's gonna show 4.6 volts with the sensor unplugged. If I unplug the sensor, 4.6 volts means 40 below zero. 40 below zero in Celsius and Fahrenheit are the same temperature. Okay, that's the place where they cross, right? So as I plug it in with a cold engine, I'm gonna read about 2.6 volts, maybe 2.8. The colder, the higher. The colder, the higher, right? You got that?
Because the hotter it gets.
The hotter it gets,
resistance for the current.
no, well, you're thinking the right way, but that's positive temperature coefficient. The hotter the resistor gets in an engine coolant temperature sensor, the lower the resistance goes. So the lower the resistance goes, the lower the voltage goes. So when you're at about 200 degrees, you're gonna be reading about 0.6, roughly. And most of the time, the fan's gonna come only about 0.45 or 0.4 or something like that. That's how that goes. Now, there are two-stage engine coolant temperature sensors that where the voltage drops off, and then it shifts gears and it jumps back up, then it drops off again, because there's a voltage divider circuit in the computer, if you wanna call it, or whatever it is. Let's see. What sensor measures the amount of oxygen in the exhaust? O2S, and how does that work? Did you guys ever, did I ever show you guys how you can test an oxygen sensor with this test stand I got out there? I've got a piece of a catalytic converter that's got oxygen sensor threads in it. And I've cut it so it's shaped like a bell with an oxygen sensor. You screw an oxygen sensor in there, and you can get on it with a meter. You'll have typically have 4 wires going to most of the oxygen sensor unless it's wideband. Conventional oxygen sensor will have 4 wires going to it. Now pay attention because it's important. The 2 wires that are the same color are always the heater. The heater is a heating element, almost like a glow plug that runs right down in the middle of the sensor, right? And it's usually got about 4 to 6 ohms resistance. When you put power and ground to that heater, it heats that oxygen sensor up so it can, it heats it up quick, where it'll start going, working really fast. Because it won't work until it hits 600 degrees, so you gotta warm it up quick, right? Okay, so what happens is, as it starts to, a rich mixture causes the voltage to drift high, and a lean mixture causes it to drift low. And so you're basically looking for, on your oxygen sensor on a healthy engine, you're supposed to see it going back and forth, constantly switching between really close to 0 and really up or close to 1 volt. Now behind the catalytic converter, you're supposed to see the oxygen sensor being lazy because the converter's storing oxygen, okay? All right, so basically you got the front one going fast, the back one going slow. Believe it or not, the one behind the catalytic converter can affect fuel trim, because the engine controller is really dead set on keeping that catalytic converter happy, because the people that type those algorithms in those engine controllers don't want the catalytic converter to burn up. So if it's getting, you can actually short that voltage back there behind it if you just want to try that, or make it think the sensor, send a false signal telling it that something's going on, and it will actually change the fuel trim to try to, fix what's going on with it, that it thinks is going on with the catalytic converter. So don't think the one behind the catalytic converter is not important, because it is. And it can do crazy things. Now, I'm not saying it will always do it no matter what kind of voltage deflection you have, but I've known of people that actually tested that with a little voltage, feed thing and they watched their fuel trims go crazy as it was trying to make the catalytic converter happy. And for years, I didn't think about the back one made any difference. Which sensor measures the temperature of the incoming air?
The IAT.
Intake air temperature sensor. Now what that does, I need to explain a little something about fuel injection here too while I'm talking to you guys. The fuel injectors are going to click in cadence with the crank sensor. The crank sensor, if you're sitting there out and if you're ever listening to fuel injectors with a stethoscope, you'll see them go click, 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 click whenever the engine's going boom, 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 boom. They're clicking at the same rate that the cylinders are working. Now, every time they click, because that's such a tiny amount of, milliseconds, you can basically, the computer can change that, how long that injector stays open every time it clicks. So what does it use to modify that? How does it decide how to put more fuel in there? If the engine is cold, it's gonna put more fuel in there. Okay, let's say you have a situation, I had a Dodge truck one time, that they gave me when I was working, I went over there to help out someone at Ford Place years ago. You know, after I came to work here, sometimes when I had a day off, I'd go over there and I'd work at the Ford Place, and I'd say, what can I help you with? And they said, well, there's a Dodge truck that's around a body shop, that came in, you know, and they did a bunch of body work on it. And they had a little cold snap that came, it was like 40 degrees outside. And he says, and it was starting just fine when it came in here, but now it won't start. And so when I started, it went to spark plug. I got the scan tool plugged in, and noticed the plug were wet. And I also noticed that I went into it was a DRB3, and I went in there and the enhanced scan tool was showing 101 degrees for intake air temperature sensor and 40 degrees for the ECT. Now what's wrong with that picture? If it's been sitting there a while, all the temperature sensors ought to be reading about the same because of the second law of thermodynamics. You guys know what that is, right? You know what the second law of thermodynamics is? That's going to be on the test. Okay, you got to know that. That basically means if you leave everything alone, it all reaches the same temperature. If you turn off the stove, the unit goes back to the temperature that everything around it is, right? That's the second law of thermodynamics. So if you're looking at 3 different temperature sensors, and it's been sitting for 3 or 4 hours, they're all going to read the same. Well, this one here is reading 100 degrees. Is it possible for the intake air temperature sensor to be that hot? No. But what is possible is if the intake air temperature sensor is open, then the enhanced part of the engine control system is going to substitute a value that it thinks will probably work. Well, if the actual temperature is 40 degrees, and it's saying I've got really hot air and a really cold engine, it's going to try to put more fuel in there because it thinks the choke needs to be closed, right? So it wets the plugs. Got that? Now, the intake air temperature sensor can either make one stumble, it can make one run rich, or you might not even know it on some of them. But it's an important input, but more important sometimes than others. That's why you got to realize that. It'll throw you a code though. Fuel injectors are what? Are they a computer sensor, both a sensor and an output device, neither a sensor nor an output device, or an output device controlled by the computer?
D.
That's an output device. Now, we talked about that before. You know, they click along with the engine controller and they pick up speed. It adds a few extra clicks when you give it the throttle too, because that's your little accelerator pump deal. Which sensor is located between the air cleaner housing and the throttle body?
TP sensor?
No.
Wait.
Which sensor is located between the air cleaner housing and the throttle body? You knew better than that. What is
Oh,
that?
I heard that wrong.
Somebody tell me. Lee, what'd you put?
Yes, C.
Huh?
C.
What about you? What about you?
Oh, D.
Mass airflow. You put C, didn't you? Did you say you put C? Who put C?
Yes,
I just put C.
Did you put C?
yes, sir.
This little guy is smart. Have you noticed that?
I just put C too.
I mean, he doesn't talk a lot, but whenever he says something, you better listen because he knows what he's talking about. Okay, ignition system creates, well, mass airflow. Well, mass airflow. Okay, here, how does the mass airflow sensor work? Some of them, believe it or not, work with sound. They've got a speaker on one side of this little chamber, and on the other side they got something that hears the noise the speaker is making. The more air that goes through there, the more it blows the sound away. You know that? Have you ever noticed there's a speaker over here that's pointing your way, and you're listening, and the air goes blowing really fast? You won't hear that speaker. It'll actually blow. You can blow sound. Doesn't seem like you would be able to, does it? Okay. All right. Let's see. But anyway, most of them, a lot of them have got a hot wire and a cold wire. And one of the things that I'm really taking the time to explain this is because Einstein said if you can't explain it to a 6-year-old, you don't understand it yourself, right? Okay, so what we got here is we got 2 wires in there. We got a little piece of plastic, a little tiny piece of plastic that's got platinum wire wrapped around it. Okay, one of those is a reference wire, and it tells the sensor what the ambient temperature is. Ambient meaning what the temperature out here is. Okay, so the other one, that little old sensor is going to bust its fanny to heat that wire up, that second wire up, the hot wire. It's going to heat it up and keep it at some temperature we'll call, let's say 300 degrees Celsius over the temperature of that other wire. Now how much current it's got to put into that hot wire to keep it 300 degrees hotter than the other wire, and it happens really fast, tells it how much air is going in there. And I'll tell you something else about mass airflow sensors. You can have a mass airflow sensor reading off just a little bit, and it'll affect the fuel trim a lot of the whole engine. If it's reading a little bit too much or a little bit too, and I'm talking about just a little bit. Most of the CAN tools nowadays read grams per second, And you know the ones that I absolutely despise are the ones that read pounds. You know, I mean, because that's not high enough resolution to read and tell you anything. I want to see grams per second, because high resolution means that you can tell what's really going on, right? All right, so the ignition system creates a high voltage, which is created in the what? Everybody's sitting there like a lump on a log.
Ignition coil,
How does the ignition coil work?
it's, you told us one day in class, I can't remember exactly how.
What? That means they just burn it in. We gotta tell you again now, right? All right. We have two windings. We've got a fine winding that's got millions of wraps, and we got a coarse winding that's got hundreds of wraps. All right, when you energize the coarse winding, it saturates the fine winding with a magnetic field. And when you collapse that field, all that collapsing magnetism creates a spark in the little fine winding. And that's basically a step-up transformer is what it is. But ignition coils have always got a metal core that magnifies the magnetic field. All right, what is it that makes and breaks the ignition coil? In other words, what is it that saturates it and then causes the field to collapse?
The, ignition control module.
Module does it, but in the olden days it was the points. And then the points moved to the ignition control module. And then the ignition control module moved into the engine controller. Right. So that's where it is. That board over there that I built shows you all of that stuff. What's used to ignite the air-fuel mixture in the cylinder of a gasoline engine?
The arc at the spark plug.
The arc at the spark plug, but I will tell you what, if the engine gets really hot, or if the compression gets really high, or if the spark is happening too soon, or sometimes you don't have little glowing coals on the inside of where the carbon whiskers are in there, it can cause detonation, which means the mix has been pulled in there with the air, the gas in the air, and it's been squeezed up here, and sometimes before it gets to the top, before the spark even lights off, there's enough heat in there to cause it to light off spontaneously. That's what detonation or spark knock is caused by. So it happens too soon, you'll be on that. Okay, a waste spark ignition does what?
Fires on 2 cylinders at a time, isn't it?
Yeah, basically that one is DSBNC. It uses one coil for 2 spark plugs. It fires 2 spark plugs at the same time, which is kind of like motorcycles. And what it does is, what's the point in that? I mean, like you've got, on every engine that's got an even number of cylinders, every cylinder has a companion. And like if you've got a 4-cylinder engine, the 2 cylinders on the end are going up and down together, and the 2 cylinders in the middle are going up and down together. But like 1 and 2 are going up and down like this. So 1 and 4, you guys hear this now, 1 and 4 is companions, and 2 and 3 are companions on a 4-cylinder. All engines have got companion. V8 engines have got companion cylinders, V6 engine got companion cylinders. The only ones that would be an exception would be what? Odd numbered cylinders. You ever heard of an engine with odd numbered cylinders? With an odd number of cylinders? 3-cylinder, 5-cylinder. Yeah.
I hadn't heard of 5-cylinder.
Yeah, there's 5 cylinders out there. You know, as a matter of fact, some of your Trailblazers have got a 5-cylinder engine in them. Unless I'm confusing that with something else. But anyway, Audis have 5 cylinders. Acura Vigor has got a 5-cylinder inline straight. It'll be an inline cylinder, it's like that. Let's see, how many ignition coils should you expect to find on a V6 engine using waste spark?
3.
Yeah, because you got 3 pairs of spark plugs, right? What term describes the order of the spark plugs the spark reaches the cylinders?
Fire in order.
Fire in order. What's the fire in order on a V8 Chevy 350?
1, 8, 4, 3, 6, 5, 7, 2.
Good answer. Did you hear that guy? He got that right. Now, the Mustang, and the, like, well, for example, 5.8 and like in that Bronco out there, if it had a 5.8 or 302, the engines look pretty much alike on the outside, but they got different firing orders. The 15426-378 would be for the 302, and 13726-548 would be for the 5.8. And when that Bronco came, somebody had wired it up like a 302.
Skip
Yeah,
it.
it was really bad. Just a minute. What you got? Who's up there? Hey, come on in here for just a minute.
I hate to bother you
Yeah.
in class.
Yes.
You know, I have parts, a lady sent LBW here,
Yeah.
her name is Joa.
Yeah, that's lights. Yeah. Yeah.
Yes, I'll leave them with you.
Oh, absolutely, leave it with him, and we'll
Okay.
get, and
Oh,
we'll
I
get it
didn't,
swapped out.
no.
No
Thank you.
problem, thank you, sir.
Thank you.
He was a lawman, I thought he was here looking for one of y'all, whatever. But he's actually delivering some parts. Now, this lady must really have some pull if she's got a lawman delivering her parts, huh? That's interesting. Obviously somebody she knows. Okay, so the firing order is, on a V6, well, on a straight six, what is it usually, you know? It's usually the same on all your straight six engines that, well, conventionally have been. 153624. Okay? All right, so you got that. Technician A said the fuel pump relay is usually controlled by the PCM. Technician B says the TBI injector squirts fuel above the throttle plate. Who's right about that?
Sir?
Who's right about that?
Say it again?
Both
Technician A says the fuel pump relay is usually controlled by the PCM. Technician B says a TBI injector squirts fuel above the throttle plate. Who's right about that?
That goes as far as
You should know that, man.
both technicians.
Both of them are right. That's right. TBI being throttle body injection. Looks like a carburetor until you take the breather off and you see throttle bodies in there. Almost a lot of them. Anyway, where's the fuel squirted in an engine equipped with gasoline direct injection?
Into the cylinder.
Right into the cylinder. Why would we do that instead of squirt? Where is it in the other kind?
Above the valves and.
Behind the intake valve. Okay, so if you put it right into the cylinder, why is that better?
Because there's no distance, they're straight in.
It's higher pressure, it makes smaller droplets. You can put it in there as a homogeneous or stratified charge. Not only can you determine when it goes in there, you can also determine, so you can't determine when the fuel goes in there on one that's put behind the valve, can you? It's not gonna go in there until the valve opens. But you can put it whenever you want to and however you want to if it's GDI. You can also have a smaller engine that's got more power. Because a lot of these vans and stuff will have, smaller ones over there. What are you guys talking about? We need to record that and play it for everybody. All right. So, let's see. Port tap fuel, let's see. What part turns the fuel injectors on and off? I'm sorry.
PCM.
A PCM, not hard to figure out on that. A port tap injection system squirts fuel where?
In the intake port near the intake
Near the intake valve. The fuel pressure regulator can be mounted where?
Be there, be.
It's going to either be in the tank or it's going to be on the rail. I have actually seen some of them on some vehicles. I don't remember which one of those is in the fuel filter, sort of. Kind of up on the top there. The idle speed is controlled by what? Oh, by the way, why do we, on the ones that when it's mounted on the fuel rail, why do we have vacuum going to the fuel pressure regulator? What's that for?
What's it again?
Why do we have a vacuum line going to the fuel pressure regulator on the ones that have it on the fuel rail? Whenever you got less engine vacuum, you need more fuel pressure so that it keeps it balanced. After a while, they found out that wasn't that big of a deal, but that's the way they did it for a long time. And you notice the throttle body injectors didn't have a vacuum line going because they were squirting above the throttle plate. All right. Where idle speed is controlled by what? B or C. That's on the modern day vehicles. Some of the older fuel injection vehicles years ago, particularly the German ones and some of the Asian ones, had something called an auxiliary air valve. And what it would do was when the engine was cold, it would let more air in there for a high and fast idle, and then as it warmed up, it would close off. And that thing used to be a mysterious thing to me until I figured out how it worked. Where's the fuel pressure regulator located on a return type fuel injection system? Return type meaning it's got, two lines come to the fuel rail, one of them return, one of them
At the end of the fuel rail.
Everybody like an answer? Well, it's wrong. It's at the outlet of the fuel rail.
Oh, it is?
Yep, it's there about where the return line goes back. Identify the throttle position sensor assembly in this diagram.
A. No. B.
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 Yeah, that's B. Well, the throttle position sensor assembly.
Why are they gonna try and confuse you like that?
A is E, B is A, C is C, D is D.
Throttle position sensor assembly is where?
B.
Now that's actually the throttle plate.
No,
No.
B is A.
like B is A. Come on.
You guys are sharp. Why did they do that? I mean, they messed all of those around and it's really confusing. All right, good answer, fellas.
Mr. Richard, I need you to sign these.
All right.